I want to let you know as we're beginning. Yeah, so again, exams are up here. If anybody didn't get their exam, they are up here. The I put the practice exam number 2 online for you last night. So yeah, so if you want to start looking at practice exam number 2, I don't know when our test is. Is it a couple weeks away? Dude, it looks like 2 weeks from today we have the practice exam. Yeah. And then the Tuesday after that's the real exam. So 2.5 weeks until the actual exam number 2. Anyway, it's up there if you want to start looking at it in advance. It's there. We'll have a day where we do it and all that. All right, let's get going. Number 6. So the domain and the range of this function. So when they give us a picture, domain and range is just width and height on the graph, isn't it? So as you look at this graph, and they're asking you domain and range. Let me come in here. So domain is just how far left, how far right does the graph go? Like what widths does the graph cover? Well, it looks like this graph right there, this graph piece right here, it goes down and closer to this line forever, and up and closer to this line, those asymptote lines forever. So it goes everywhere left, but it doesn't quite make it to, what is that? Is that -3 or -4? Is that what it is, -4? You'll be able to tell on your thing a little bit better. Yeah, I think it's -4. That x right here is -4, I guess. So, so it gets really close to -4, it looks like. But does it... Oh, it's because I wrote domain over the top. I think, why can't I see? Yeah, it's right there. There we go. Yeah, you're right. It's -4. Yeah, because there's -3, there's -4. Right, so it is. It's -4, like you guys said. So it's -4 there. So it gets real close. And then on the right side, the graph goes, right forever and gets super close to -4. So basically it hits everything but -4. That's why I said that right here. The domain is everything except x cannot be -4. Everything else it hits, does it? Goes right forever, left forever. Good? Range? Range is height, right? So if I, write range... Range is basically how high and low. What vertical coverage does the graph do? Well, it goes up forever, down forever, but it never hits the height of, what is that? Looks like -2, doesn't it? Yep. Never hits the height of -2, so I say all y values, all heights, except not -2. That's the range. Good? Moving on. Question B, the intercepts. That's the places where it hits the grid lines. Let me erase what I'm doing on here. Where does the graph hit the grid lines?
I see one place.
Yeah, 0, 0, that's it, huh? That's the only place the blue graph is intersecting the grid lines. So the intercepts are 0, 0. That is both the x-intercept, it is also the y-intercept, because it's where it hits both grids. Horizontal asymptotes, right? Sideways dotted line, well, here it is right here. So what is they want the equation for that thing. So what's the equation? Well, it's a line equation. It's just a flat line. It hits, what axis does it hit? What axis does this flat line run into?
Y.
The y-axis. Where? At -2. So that's it. Y equals -2. That's the equation of that horizontal dotted line. The asymptote line. Does that make sense? It hits the y-axis at -2. Now, yeah, the next one's the vertical. What does the vertical dotted line do? Which axis does it run into? It runs into the x-axis at what? -4. So that's just x is -4. Good enough? Oblique, that means diagonal. We're going to get to those in a couple minutes. We don't have any. There's no slanted or diagonal dotted lines on this graph. There's only straight up and down and straight sideways. So no, what are called oblique. No oblique asymptotes, no diagonal asymptotes. Good? So that's all the questions on that one. I'll move on. Unless you want to stop me, feel free to. Okay, so number 7 here. So we got a diagonal asymptote. So let's start with the domain. What's the domain of the function? What do you think? How far right, how far left? What's the sideways x coverage of the graph? How far does the graph go right? How far does the graph go left? Well, it looks like it's going to go forever right here and up, and forever left here and straight down. So it's going to hit all it's going to go left forever. Here it's going to go right forever. So up and left, down and right. So it's going to go left and right forever. The only thing it's not going to hit is straight on 0, huh? So it's just the domain is x cannot be 0, but it can be anything else. We good? Just doesn't hit the middle, does it? Is that making sense? And then range is the y coverage, the up-down coverage. Whoops, I guess I shouldn't really erase it. Yeah, how far up and down? Well, again, this one goes up forever. This one goes down, up and left, down and right. So up forever, down forever, hit it. Is there any heights it doesn't hit? It's good. It hits everything, doesn't it? All reals. The range would be, the domain. Well, that's actually the domain answer, but it's all reals. Right? There's no heights that it skips. There's no horizontal dotted line like there was in the last one. See, this last one had a horizontal dotted line, so it never hit the height of down 2. It never did that. So we said y cannot be -2. But on this one, there's no horizontal dotted line blocking some height. It goes, right? This piece, right? Even just the left piece right here, just this piece covers all heights, doesn't it? It goes up forever, down forever. No skipping anything. So all reals on the range. Intercepts, where does this graph hit the axes? They're just telling you right there, 1, 0, and -1, 0, huh? Just boom, boom. They're just giving those to us. -1, 0, comma, 1, 0. Those are the 2 points where our graph hits the grid lines. Let's keep moving. Horizontal. What are the horizontal asymptotes?
None.
Yeah, there's none. There's no flat asymptotes, are there? How about vertical? What are the vertical asymptotes? It's got that one dotted line right in the middle. Now, what's the equation for that thing? Which axis does it hit? That vertical line runs through the x-axis, doesn't it? So it's x equals 0. Right, this vertical line runs through the x-axis right at 0. So it's x equals 0. That's the vertical. Now, finally, the new part, the oblique. It's got one of those. It's got a diagonal dotted line, doesn't it? Remember, oblique means diagonal or slanted. So basically, I need the equation for this dotted line right there, which is going to be y equals mx plus b kind of an equation, isn't it? Because it's a line. That dotted line is a line, right? So how do you get the equation of a line? Y equals mx plus b. What is m? Slope, isn't it? That's rise over run times x plus b. And what is b? Y-intercept, where it hits the y-axis, huh? You with me? Remember what the m is and what the b is in the y equals mx plus b equation of a line? So, for this diagonal dotted line, what is his rise over his run? Well, they're giving me a point, right? Clearly it goes through the origin, 0, 0. So, hey, so I know the y-intercept 0. Got that, right? The b is 0, right? This diagonal dotted line goes through at the origin at a height of 0. The y-intercept is 0. The b is 0. Okay, now from that dot to the dot looks like over 2 down 6.
-1 over
What's
3.
the rise and run? Yeah, it's going to go down and over, down 6 over 2, isn't it?
What do you want to simplify for?
And then we'll simplify that. But so far so good.
Yeah.
Down 6 over 2, rise over run. Down 6 over 2, then you reduce that. That's -3x. There's the equation of the dotted oblique asymptote. And that's the end of the problem. Questions on that one? Are we happy? I'm aiming for your happiness this morning. Because you'll be happy when you know the stuff, huh? All right. All right, so we have y equals -6 plus 1 over x. Okay, so we're getting back into our graphing thing. We're going to have some graphs on this exam, just like we did on the first exam. There'll be part 1, part 2. You can see on the practice exam exactly what it'll be like. It's out there for you now. Part 1, part 2. Part 1 will have a few graphs and a few other things you'll see when you look at the practice exam. And so this remember what y equals 1 over x, forget about the negative 6 for a minute, just what does y equals 1 over x look like? Do you remember that one? That's one of our big 6, original 6, that has the 2 dotted lines right on the asymptotes. I call them the crosshairs, just to help you remember, right? It's the 2 dotted asymptote lines. And then the graph is the 2 branches diagonally across from each other, the first and third quadrants. Remember that? That's one of our big original 6 that we memorized or put on your 3x5 card. Want to put those down again, you're going to need those. So anyway, so there's 1 over x. So the question is, what is that minus 6 added to the front going to do to that graph?
Move it down.
Yeah, the minus 6, that's a down 6, huh? Is everybody good with that?
It's connected to the y.
Because that's a y effect. Now where would the minus 6 be if it was like a right-left thing? It'd have to be in there with x, like it'd be something like this. 1 over x minus 6, like that. See, if it enters into x's little world, and what's x's little world? Living underneath a 1, at least in this equation, right? And if you do square root of x, then x's little world is in the root. If you do x squared, then x's little world's under the 2, etc., right? All of our graphs have x's little world and outside of x's little world. You tracking with me? Right, all of them. There's x squared, x cubed, square root, cube root, absolute value, and 1 over x. There's always entering into x's little world or being outside of x's world. So if it was like this, then it would be in x's little world. It would be a right-left kind of thing, wouldn't it? In fact, what would this be? This would be right. Because remember, x is opposite. So that kind of equation would grab this entire graph and move it right 6. If they put the minus 6 down there in x's little world, it's opposite for right-left. But with the minus 6, the way they did it up here, it's going to be a down 6, isn't it? Down 6. So it's going to grab this entire graph and move it down 6. Now, the easiest way to do that, guys, is to just grab it right at the origin, because everything's going to move. The crosshairs, the branches, everything. And the easiest way to do that for all these graphs, is just grab them in the middle, grab them at the origin, and move them wherever they need to be moved. So I'm going to grab the origin and move it down 6. 1, 2, 3, 4, 5, 6, right there at negative 6. And then, well, I need more room. Let me try that again. Need a little more room. Move the whole thing down 6. So 1, 2, 3, 4, 5, 6. There we go. Down 6. And then put the crosshairs down first. Just makes it easier to fit the graph around it. Yeah, so first put the crosshairs down. So for the 1 over x graph, just grab the origin, move it down 6, but put the crosshairs in position first, and then you know where the graph goes. It goes here and here. So which one of those is that? Which one? A, B, C, D. Looks like it's been moved down 6. It's B, isn't it? Looks like B. Down 6 and got the 2 branches. We good on all that? All right. All right. What's that going to do? So we have y equals 6 over x minus 2 squared. Okay, so to first starter, before we get into what the 6 is doing and what the minus 2 is doing, let's remember the basic form of not 1 over x, but 1 over x squared. I don't know if I've showed you this. I don't think so. Have I? So what does 1 over x squared do? It's very similar to 1 over x. First off, it's got the crosshairs, you know, the 2 diagonal asymptote lines like that. Okay. But the only difference, in fact, let me write them both at the same time. Probably be helpful to have them both on there. So 1 over x, let me put that over here again. 1 over x has the dotted lines, and the branches for the 1 over x are here and here. So the only difference is now the branches for the 1 over x squared. Anybody want to guess? Instead of 1 up, 1 down, x squared, can that be negative? Never can be negative, huh? It just makes both branches up instead of 1 up, 1 down. Because x squared is always positive, huh? X squared can't be negative. That's the only difference. Makes sense, huh? So x squared, everything's got to be positive. Both branches are up like that.
So
Okay.
This will end up being one of the things where depending on whether the power is even or odd.
Yeah, kind of like that. Yeah. So remember the basic form that x squared both are up, 1 over x, diagonal. Now I say diagonal because remember they can flip things and do funny business, right? So for example, if they said, okay, I want you to now graph negative 1 over x squared, what would a minus multiplier in front of the thing do? It would grab the two branches and they would be down here, huh? Because it just flips the graph, right? And what if they said, okay, I want to do minus 1 over x? That would grab the graph and flip it. This one would go up and this one would go down, huh? So with that in mind, to try to help you recognize on the multiple choice test and all, is the easiest way to think about x squared is these guys are always across from each other and these guys are always diagonal from each other. Whether it's flipped or not, that'll always work. See what I'm saying? Because if these guys flip down like this, they're still across from each other, aren't they? They're always across. If they've been flipped, they're still across. If they're normal, they're still across. Whereas these guys, if they were flipped, they'd go like this. Then they'd be diagonal in the other two quadrants, wouldn't they? So they're always going to be diagonal. Does that make sense? Easy way to keep it all straight? Okay. So with that in mind then, let's go over, get rid of that minus there, and let's do our actual graph. So we know the basic. The basic look is this, a couple of branches across from each other, because it is x squared kind of format. Now, what is that minus 2 going to do? Yeah, that's in x's little world. X does opposite, right 2. Right, we good so far? You guys enjoying this? I think this is fun. How these little tricks move around and flip and all that stuff. All right, right 2. I hope you're enjoying it. If you can get it down, it'll be fun. Right 2, and I think a lot of you kind of do. Right 2. And now, what's that 6 going to do? That 6 can be a little tricky. Do you realize? Let me help with that. Do you realize that a 6 on the top is the same thing as a 6 multiplying the front? I think if you see that, you'll be like, got it then. That's the same thing. You know what it is that makes pre-calc hard and calc as well? It's not the graphs. I think you can get those down. A lot of times what it is, it's all this kind of little picky stuff. It really is. So I'm eager to help you with all this little picky stuff. Please ask. That's what I used to ask my teachers. I'd have lists. Right? This would be the same. This would be the kind of thing when I was a pre-calc calc student at junior college. I went to junior college up in Sacramento. I would go, why did they move the 6? I would write down, when I'd see them do that in the homework or whatever. I would write down, number 10 in section, whatever we're on, 4.2, Mr. Pinnell. I'd have a list and I'd find Mr. Pinnell in the hall. Why did they move the 6 from the top of the fraction to the front of the fraction? Can you do that? When can you do that? Why can you do that? Can you always do that? I would ask. And Mr. Pinnell would say, well, yeah, because any whole number in the front is really 6 over 1, right? Any whole numbers over 1, if you multiply them back together, the 6 would go right to the top. And then, boom, I've got it. If you don't got that, it's going to hamper you. It's going to show up all the time. It's all that little stuff. Really ask. Make notes when you do the homework. Anything that seems strange, that's really it. That's how you learn this stuff. So, yeah, so know that to be in the top is to be in the front. It's the same thing. It doesn't matter. Why? Because anything alone is really over 1. It's the same as the top. So, with that in mind, now you know, huh? Looking at it that way, you know what that 6 is doing. It's not adding, huh? It's not an added 6. It's a multiplied 6. So what does that mean that multiplied 6 is going to do? What happens when you multiply any of these guys by 6? Is it an X thing or a Y thing? First off. Is it an up-down thing or a sideways? Yeah, it's up-down, isn't it? Why? Because it's not like this. It's not next to X in X's little world. It's not like that. That'd be an X thing, wouldn't it? If you enter into X's world. It's not like that. So it's a Y thing. So when you multiply by 6 with a Y thing, what's it going to do? Stretch it. 6 times as tall. It's a vertical times 6 stretch, isn't it? It's going to make it go up 6 times as fast, a vertical stretch. So, now, that's a little funny. What I mean, not a little funny. I just mean, you aren't going to be able to see that much. I mean, a little bit. It goes up forever already, but it's just going to go up faster. 6 times as fast. Okay, so which one of these graphs, then, has been moved right to and has branches going up? Well, they all have branches going up. Which ones have been moved right to? Do you see that there's 2 of them? This one's a little tricky. This is a little more advanced problem here. They're being a little more subtle with their multiple choice. Do you see it? This one has been moved right 2, and D. A and D have both been moved right 2. B and C are out. You know, they've been moved left 2. That's not correct. So you with me so far? We got to decide between A and D, right? A and D have both been moved right 2, right? The crosshairs are at right 2. The crosshairs are at right 2. Well, okay, so now which one of those is it? Well, now we get into the times 6 thing. What does the times 6 thing mean again? It means it's going up faster, 6 times as fast as the normal one. So which of these graphs, A or D, is going up faster? It's a little hard to tell. It's actually D. It's D. Now why? Why? Well, probably the easiest way to get your bearings is pick a point. Remember what I said to do? If you're ever on the test, what are you supposed to do if you're taking the test here in a couple of weeks and you're looking, you go, it's A or D, I don't know which one. Make a table, right? Which means just find a point. So, and just one, if you're ever unsure, plug in a point. And do something easy, not something tricky or fancy, just something easy like this. Look right here. How about right there at 0? Is that right? Well, where's this one at x equals 0? Well, he's barely up at all. First off, that's enough if you just observe that. Look at that. On the x-axis, on the y-axis at x equals 0, this A graph is barely up at all. It's not even at 1. It's barely above 0. This one at x equals 0 is past 1. See, he's going up faster, isn't he? See how that works? But if you're not sure, just plug in x equals 0 to the actual equation and find out where it should be at x equals 0. If you plug that in, you'll get 6 over 0 minus 2 squared. What's that? 6 over 4. Divide in your calculator, 1.5. It should be at 1.5, which is exactly where that dot, where this one seems to be, right? 1.5 at 0, over 0 up 1.5. So indeed, D is our answer. Is that good? Make table if you're unsure. Just 1 point, I mean. When I say make table, just find 1 point. Questions? You good? Do them all, but I'm going to run out of time. I don't want to do that. All right. Okay, so y equals negative 6 over x plus 6. Let me give you just a second, rather than me talking through it. So if you don't have to, but if it helps you, you could just stick that negative 6 in the front. You don't have to. But just know that, though, right? Know that's a minus 6 multiplier in the front, effectively, isn't it? To be in the top is to be in the front. It's the same thing. So take it from there. All right, so it's basically 1 over x graph. It's a 1 over x graph, so you know it's the two branches like that, but two things, huh? There's 2 things. What's the x plus 6 going to do? Left, so remember x is opposite, so left 6. So it's going to grab the crosshairs, and it's going to move them left 6. So let's do that. Let's grab them crosshairs and go left 6. So 1, 2, 3, 4, 5, 6, right here. So that's where it's going to go. Like that. Good so far? And now the branches are normally here and here, but what's that minus 6 going to do? It's a vertical flip, isn't it? Because that's a y thing. It's a negative number multiplied. So that's going to flip it vertically, isn't it? So this branch will go. So basically you're grabbing the x-axis and just like a rotisserie, right? You're just turning the whole graph about the x-axis. So this branch will go up here, and this branch will go down there. That's where the graph will actually end up being. Is that making sense? So which one of those does that? Is it C? Yeah, it's got to be C, doesn't it? Yep, there it is, left 6 with the branches that way. We good? Questions? All good? This one will require just factoring the bottom, and then it's the same. So yeah, so this one You can see that up there, yeah. I'm just gonna do this one super quick. I'm just gonna factor that bottom. It's x plus 8, isn't it? Because, you know, multiplies to be 64 and adds to be 16. So that's minus 1, x plus 8 squared.
Well, then that's just,
Yeah, so what's the x plus 8 do?
it just cancels out and goes to a positive.
It's gonna be left 8?
Yeah.
Because x is opposite. So it's gonna be a left 8, and the negative 1, that's the same thing as negative 1 multiplied. You know, you don't have to write it, but just know it. It's a negative 1 multiplier, effectively, which means vertical flip. So it's, normally branches are up here because it's x squared. This is x squared, right? Both branches up, but it's been flipped. So both branches are down, and it's been moved left 8. So which one is left 8, both branches down? Isn't it C? Left 8, both branches down. C it is. Good, good. I move along quick. I'm going to keep going. I want to.
5x squared up there.
Yeah, the trick on this one, let me write this one for you. Y equals 5x squared minus 4 over x squared. Trick on this one is you got to break those up over. You got to do a little algebra first. You got to break those, because we can't handle it the way it sits. It's just weird looking. It's not anything we're used to. So you have to just break it up over the common denominator like that. Just separate it, you know, they're both over the x squared. Good so far? That's just common denominator break up there. And then these guys cancel, huh? So it becomes 5 minus 4 over x squared. Is that good? By the way, you know, it just occurred to me. You might think, well, couldn't we just cancel those x squareds right back here? You actually can't. It's illegal. I don't know if you know. That's a real important rule to know, especially as you move on in this course in calc. Pluses and minuses glue things together. Have I talked about that? Mm-hmm. Costco, I do my whole Costco thing. It's like when you shop Costco, things are packaged together. Mm-hmm. You know, they're plasticking the milk now. Every time I go out to the fridge and I go to grab a milk, they're always, I mean, they really are into that now. They're plasticking the milk together. So you've got to cut the even in my own fridge, I got to cut the plastic to get just one milk out. You know, anyway, so that's what pluses and minuses are like. They like glue things together, which means if you want to cancel something on this 5x squared minus 4, you go like that or nothing. Like Costco, you buy the whole package or nothing. You can't break the bond, right? That's pluses and minuses. Pluses and minuses are glue. So that's what tells us, no, you may not do that. You may not cancel the x squareds like that when there's a plus or a minus. If that was just times 4, if that was just 5x squared times 4, totally, you could totally just cancel those x squareds. No problem. But it's the pluses and the minuses that make algebra hard. It really is. It's the pluses and minuses that do all the difficult things, especially glue things together. That's why I came over here and separated them. And now you see I can cancel these guys because that's just 5 times. That's just 5 times x squared. So no problem. You can cancel it there. Everybody see the difference in the rules? Mm-hmm. That's why that's okay to do. Okay, so we get to here then. Is that something we're used to? It actually is. It might look a little funny to you. You don't have to rewrite it, but if it helps you, you could do it like this. This is minus 4 times 1 over x squared plus a 5. You don't have to do that, but that might be easier to look at for you. That's the same thing, and that's clear now, isn't it? Right? Mm-hmm. That minus, again, the 4 on the top is the same thing. I'm sorry, it's a minus 4 on the top. Just put it in the front. We can always do that's the same thing because that's over 1. Go right back to the top. And the 5, that's a positive 5. I'm just going to put him at the back. It doesn't matter, front or back, whatever. But I think it's easy to look at. So when you look at that, what is that 5 going to do?
Go up 5.
Up 5, because he's a y thing, not an x thing. What's that minus 4 going to do?
Flip.
Vertical flip. So basically we're taking the x squared graph, which is the 2 branches that are normally up. Then they're going to go down. They're going to flip down. And then the whole graph is going to move up 5. So take the whole graph now and move it up 5. So up 5. So 1, 2, 3, 4, 5, right to there. Move the whole graph up 5 so that the asymptote lines go up 5 and the branches have flipped down. So up 5, branches down.
A.
Is it not D? Why is it not D? Oh, that D's at 4.
Yeah.
Are they tricking us? It looks like D's at 4, I think. 1, 2, yeah. They're just
Yeah,
they're being tricky. They only put that at 4, so it is A, A's at 5.
You nearly got fooled.
There we go. Good on that one?
Yep.
All is well. All right. Now we're changing gears. Now we're going to find asymptotes from an equation. So there no more picture. Have you seen the way this this book is working? I think it's good. It's very helpful. Skills you need for calculus. That is, they give us pictures. That's what they did about 20 minutes ago. They were giving us pictures and saying what's the horizontal, what's the diagonal, or what's the horizontal, vertical, and diagonal asymptotes from pictures. Sometimes they give us pictures and ask us domain and range. Then they switch gears, don't they? And they give us an equation, no picture. And they ask all the same questions. What's the vertical asymptote? Horizontal, oblique, what's the domain, what's the range? So we're learning to work from pictures and we're learning to work from equations, so that's all solid in our mind. Okay, so how do we do it? How do we take just an equation now and answer all those same kind of questions? Well, I'll tell you. Here are the rules. So vertical asymptote, I just need to give you the methods. So to find a vertical asymptote, it's almost exactly like a denominator. Domain, which is denominator. Denominator equal to 0 and solve. Just like we do for finding where the domain problem is. Basically, wherever the bottom of the fraction is 0, that's not allowed, right? That's where there's going to be a vertical asymptote line because you can't go there. That's what that means. So on this one, just grab that denominator, x plus 2, and set it equal to 0. I know for domain, we set them not equal to 0, huh? Because we're saying you can't be that spot. For vertical asymptotes, we're saying equal to 0, because where you equal 0 is where the vertical asymptote will be. It doesn't matter. If you put not equals, it's all the same thing, basically. So, -2. So what we're saying, we're really saying two things, aren't we? We're saying on the graph at x equals -2, right, -1, -2, there will be a vertical asymptote line. And you can't go there. That's right, because if you put -2 in the original, it makes the denominator 0. So it makes it undefined. Remember 0 in the bottom of fractions, undefined, underneath undefined? That's why it both makes a vertical asymptote and domain is not allowed there. That's why you can never touch a vertical asymptote line. You can hit horizontals, but you can never touch verticals because they're not in the domain. Denominator 0. All right, so there's the vertical. That's pretty easy. Horizontal is a little more complex. So for the horizontal asymptote, I'm going to give you a series of 4 different conditions. But let me keep it simple to start with. What you do is take highest power terms, top and bottom. Let me just say only keep the highest power terms, top and bottom. Skip the small stuff. What am I talking about? We have our function is y equals 8x over x plus 2. So as you look at these guys, you're going to say, all right, the 8x and the x, so in other words, 8x over x, is all I'm going to keep. I'm going to get rid of that 2 because he's a lower power term. Terms are things separated by pluses and minuses. So x and 2 are separate terms. I'm only keeping the x because he's higher power. So on the bottom, if you had like x cubed and x squared and 7x and 10,000, I would only keep the x cubed. Does that make sense? Keep the most powerful term on the bottom. Keep the most powerful term on the top. Okay, why? Why would you? Well, hold on. Let me get to the answer. And then, if you just have 8x over x, boom, there it is. Y equals 8. That's the answer to this. That's the horizontal asymptote. Y is 8. So, let me do it this way. N equals numerator power. D equals denominator power or degree. And case 1, if N equals D, which is what we have here, the power is first on the top, the power is first on the bottom, right? They're both just x to the first. If they're equal, then you have a horizontal asymptote y equals a over b, where a and b are numbers in front, which is what I just did. Right? This is the A and the B. It's 8 over 1 or just 8. All right, let me stop there and let you digest that and write that down. So we're done with that problems. Everybody see. There's more to the horizontal asymptote story and problems to come. But there's the first case. So everybody see what I did. So when you're doing, we did vertical. Vertical is simple. Just let me kind of get that out of the way. Here's the vertical. That's simple. That's just denominator 0, solve it. You know, piece of cake. Nothing more. That's the whole vertical asymptote story. There's nothing more to that story. Horizontal, we're just getting warmed up. So horizontal, what you do is you take the highest power term in the top, highest power term in the bottom. So skip the plus 2, just 8x over x. You look at the power on those guys. N is the numerator power, D is the denominator. If those powers are equal, if they're equal, then basically they just cancel like I showed here. And it's just A over B, and A over B means the numbers in the front. So it's just 8 over 1. It's just 8. So the answer is, and it's Y equals 8. We kind of lost that Y all the way back there. So the horizontal is Y equals 8. Remember, horizontal lines go through the Y, they cut through the Y axis, don't they?
Yeah, that's complex.
Does that make sense?
In the future.
So if I went to draw this thing, let me be clear here. If I went to draw this thing, up at 8, 1, 2, 3, 4, 5, 6, 7, 8. At Y equals 8, cutting through the Y axis at 8. There's the X axis. Cutting through the Y axis up at 8, there would be a horizontal dotted line. Horizontal asymptote for this graph. Is that good? Okay. I'll talk about why this power thing works in a minute. Let's just get a couple more under our belt, then we'll talk about why that is even true. Okay, so number 16, y equals x squared over x to the 4th minus 256. Let's start with the vertical. Vertical is easy, right? Start with the vertical. So for the vertical asymptote, you take the denominator. We don't care about the numerator. Just take the denominator and say, denominator, where are you 0? Wherever the denominator is 0, it's, 0 underneath is undefined. That's where there'll be a vertical. So can you factor that? Remember factoring? This would be x squared, x squared. Take 256 and root it on your calculator. The root of 256 would be 16. Yeah, 16. So that means it's 16 times 16, huh? So that's plus 16 minus 16.
Yeah.
Good so far?
Yeah, I follow.
And now what if this had been plus 256?
And you just wouldn't be able to do it.
Then you can't factor. It would not be plus 16 plus 16. That's not true. Does everybody know that? Really important you know that. I know I keep beating that drum, huh? As you move on into calculus and stuff. Really important. So if that had been plus, it would have wrecked it. We just would have said no answers. There'd be no vertical asymptote. Anyway, it's minus. We factor it. Now, we can go further, though. This guy will break into 2, won't he? X plus 4, x minus 4. Whereas this guy just comes straight down. Everybody good? Again, see, this guy can't. It's not x plus 4, x plus 4. It's not true. That'd make a plus 8x in the middle, huh? So it's not right. So anyway, and that's as far as we can go. So what x value can you plug in here that would make this piece 0? Nothing. There's no way to make that piece 0. Right? Anything you plug in squared is positive. Add 16, it's going to be positive. It's going to be over 16 even. It's not going to be 0. So nothing coming out of there. What could you plug in here to make this piece 0?
Negative 4.
Negative 4. What could you plug in here to make that piece 0?
4.
Positive 4. So those are our two verticals. So the verticals are x equals negative 4 or positive 4. Those are the two vertical asymptotes. Good so far? for the verticals, all that factoring. Factoring, I'm glad to help. Come see me office hours or Roberto, get the help you need. Make sure you can factor. It becomes increasingly important as you move forward. Okay, so now let's do the horizontal thing.
Okay.
And we're going to have a new step here. So horizontal asymptote, go ahead. What are you supposed to do? Just take the most powerful term in the top and the most powerful term in the bottom. That's all we care about. Like that. We don't care about that 256. He's a less powerful term. Okay, now, what's the numerator power 2? What's the denominator power 4? Case 1 was if numerator equals denominator, then it's just horizontal asymptote y equals a over b. We said that. That's not our case here. Their powers are not equal, are they? Okay, we need case 2. If the numerator is lower than the denominator, that's what we have. Numerator is lower than the denominator. Denominator power is greater. What does that mean? Horizontal is y equals 0. So our answer to this question, the horizontal asymptote, is y equals 0. So that means if you went to graph this thing, I'd come up here and do a little graph. If you went to graph this thing, you would find a horizontal asymptote right at 0 and a vertical at -4 and a vertical at +4. And the horizontal right on 0. Those are the asymptote lines you'd find for this graph. Is that making sense?
Mm-hmm.
Now I want to start to give you the why. Why? Why, first off, do we only do the highest power on the top and the highest power? Why can't I skip the 256 like that? I thought that was illegal and all that kind of stuff. Well, it's because with a horizontal asymptote, sideways dotted line, what you're really thinking about is in behavior. Remember how we talked about in behavior with some of those other functions the other day? Because what? Because a dot, it's all about what you do way off to the right. Nobody cares in here, whatever. But it eventually approaches that horizontal. Maybe, right? Something like that. That's what horizontal, eventually you start to get there. So that means as you go way off to infinity, end behavior is really the question when you're talking about a horizontal asymptote. When x is something big like 10,000 or 10 million, when x is way off to the right, in the end, what happens? That's the question pertaining to horizontal asymptotes. So, if you're thinking about plugging in gigantic x numbers, end behavior, 10,000, 10 million, etc., do you see 256's chump change? It's nothing. If you're plugging in 10,000 to the 4th power, what is 10,000? I don't know. It's crazy big. It's more than a trillion. If you have $1 trillion, you don't care about losing 256 bucks. It's nothing. Right? So that's the point. As far as if you're plugging in, if you're going way off to the right, all that's going to matter is the most powerful term in the top line. The other stuff is going to become negligible. So small it doesn't even affect anything. Only the biggest power top and bottom will matter. Okay? And notice the bottom is more powerful. 10,000 you're plugging in 10,000 again, remember, or 10 million or 10 billion. If you're plugging in some gigantic number squared, so times itself, that's going to be really big. But down here, it's times itself 4 times.
Which is
way bigger. The bottom is going to overwhelm the top, isn't it?
Oh, yeah.
The bottom is way bigger. So in the end, after you reduce the fraction, the bottom will still have a bunch left, and you'll have something like 1 over a million, for example. So what is 1 over a million? If I say, hey, last night I was hungry, but I was only able to eat 1/1,000,000th of the pie.
Oh my goodness.
How much pie is that?
You gotta be a skilled cutter for that kind of slice.
That's just the smell of the pie, is all that is, right? That's not even a crumb.
It's like, were you trying
That's
to put
0.
Like a bologna slice in your sandwich?
That's why we're saying it's 0. Does that make sense? That's why we're saying it's 0. Because when the bottom wins, it's like a tug of war, right? It's that the top is trying to pull the graph up, and the bottom of the fraction is trying to pull the graph down. If the bottom wins, if the denominator power is greater or the numerator is smaller, same thing, then the bottom wins the tug of war and he pulls the graph flat. See how this dotted line is flat? Meaning that graph is eventually, in the end, going to flatten out. The bottom wins the tug of war. That's what's happening there.
At that point, it's like a 2-year.
Okay, so vertical, so I'm just going to whip this one out. Vertical asymptote, denominator, 2x squared minus 3x minus 20 equals 0. I'm just going to factor it super quick. I'm glad to help you if this isn't easy for you. 4 and 5, it's going to be 4 and 5 in some combination. 10 and 4, no, it's the other way. 5. Oh yeah, the 4 can't be with the 2. Remember, you can't have two numbers the same parentheses that have anything in common. Do you remember all that from factoring? The 4 cannot be with the 2 because they'd have 2 in common. So these two make 5x, these two make 8x. Yeah, that can make minus 3 if the 8 is negative. So this is positive, this is positive, this is negative. Yep, there's the factoring. That does make the middle term of minus 3x. That's correct. So then what do? You set each one equal to 0. Grab the first one. 2x plus 5 is 0. Grab the second one. X minus 4 is 0. Solve them both. Jump the 5 over. 2x is negative 5. Divide by 2. Jump the 4 over. So 4 and negative 5 halves. Those are the two vertical asymptotes. So I just factored that. Basically, I just fiddled with it until I knew it would FOIL and go back to that. That's what I'm doing. Does that make sense? I just kind of worked out the combination. The FOIL. F-O-I-L. Right? Front times front. Last times last. And here is the inner, inner, outer, outer. Makes the middle. The OI makes the middle term. Plus 5 minus 8 makes minus 3. I know I whipped up that quick. Come see me if that's hard for you. I'd be glad to help you. But it's basically just you guys got to practice foiling. You know, you don't. If you're looking at what I'm doing and it seems mysterious, don't worry. It's my little technique, but it doesn't matter. In the end, you just if you're looking at this and you're not sure it's right, foil it. That's really what you need to do. You don't need a magic formula. You just need to foil and foil and foil and foil and foil until you can just basically look at that thing and know that it does become this. That's what you need. It's just more and more and more practice foiling. All right, anyway, let's go to the horizontal. Can you do the horizontal?
Yeah.
Let me give you 30 seconds. What's the horizontal asymptote? It's one we've already done. It's not a new one. So horizontal is in behavior. It's way off to the right. So all that matters is most powerful term in the top, most powerful term in the bottom. Everything else is chump change. Doesn't matter. Fades into oblivion. Just the most powerful term in the top and bottom is all that will matter in the end. And those are same powers. Boom. 5 halves. Remember that's numerator is 2, denominator is 2. They're equal, right? So when numerator equals denominator, that was case 1. Y is just A over B. It's just 5 over 2. Done. Is that good?
Uh-huh.
Horizontal. That's at 2.5. So this one would have a horizontal up at 1, 2, 3, at 2.5. Yep. 1, 2, 3. Because 5 halves, you know, is 2.5. So it'd have a horizontal asymptote at 2.5 is what that means. And it'd have a couple of verticals, but we better move on.
Yep.
Good. So this is question 18. Oh, I just hit the button. There we go. Question 18. Okay, so the vertical is simple enough. Vertical asymptote, just grab that denominator. Say, hey, denominator, you got to be 0. Jump that over. 4x is minus 7. Divide by 4. X is minus 7/4. Good so far? Mm-hmm. That one's simple enough. Now, the horizontal will be the worst case scenario. So this is the hardest case here. Horizontal asymptote. So what do? Highest power in the top, highest power in the bottom. So we're talking about y equals 8x squared over 4x. Numerator power is 2. Denominator power is 1. Good so far? Uh-huh. Case 1, remember if they're equal, which they're not, it would just be y equals a over b. That's not what we have here. Case 2, if the numerator is lower, That's not what we have here either. The numerator's bigger. That would just be y is 0. Case 3. If the numerator is greater than the denominator by 1, by only, let's say by only 1, what do you do now? That's what we have. The numerator is greater than the denominator by only 1. Well, what that means is, it's not exactly like this, but it's kind of like you could, and I'll explain what I mean by kind of like in a minute, but it's kind of like 4 goes into 8 2 times, x cancels x, and you have y equals 2x, right? It's kind of like that. What is that? But it's going to have a b term also. That's the m. It's linear. That's a line. That's a slanted line. This is the oblique case. It's going to have an oblique, not a flat, not a horizontal asymptote, but a slanted. You see, when the numerator powers 1 more than the denominator, then when they cancel, you get first power, which is a line, a slanted line with a slope. Oblique asymptote. Now, I keep saying it's kind of like. This isn't really right. Pretend that didn't happen. You can't really do that. That isn't really quite the whole story. What you have to do is you have to do something terrible. You have to long divide the denom, the bottom, into the top. You have to long divide the bottom into the top. Now, it's probably been a long time since you've done that, or maybe you don't remember it at all, or maybe never done it. That means you got to take the 4x plus 7 and long divide, and I need a little more room here. You got to take the 4x plus 7 and long divide it into 8x squared plus 2x minus 21. Now, it'll be 2x, and then there'll be a b term. So it's like that thing was partly right. Now, have you done this before? It's kind of a messy business. So let's give it a go. So long dividing, you say, okay, whatever you put up here times the 4x to match the 8x squared. That's how long dividing works, right? Just think about numbers. If you did 31 into 675 or whatever, you would just say, what times 3 makes 6, wouldn't you? And you'd put a 2 there. But the 2 wouldn't just multiply the 3, he'd also multiply the 1. And you'd write down 62, wouldn't you? And then you would subtract, right? Same thing here. Put up here, what times 4x will match 8x squared, right? What times the front will match the front. What times 4x makes 8x squared? 2x, as we already saw and predicted, right? 2x. Now, what will that 2x do? Exactly what this 2 does. It'll go to both. And you write them both right here, don't you? So 2x times 4x, 8x squared, and then 2x times 7, 14x. It's exactly what we do in number long division, right? Just a little messier. Everybody good so far? And then what do? Subtract. 8x squared minus 8x squared, gone. 2x minus 14x is minus 12x, isn't it? See what just happened there? 2x minus 14x minus 12. Good. And now what do you do with the minus 21? Bring it down. Right, like over here I would subtract, then I would just bring down the other 5. So I just subtracted, bring down the minus 21. Good so far? See what we're doing? Just like number long division. Now, what would you do on your next step? We just got to do it again. Now, 65 is weird, but what if I had, let's just pretend I had 95 over here. If I had 95, what would I do? What would I do for my next step up with these numbers? What would I put up here? What would go right here? I would look at the 3, I would look at the 9, front in front, right? And I'd go, what times 3 will make 9? 3. And I'd go, okay, put a 3 there, wouldn't I? And that 3 would go boom, boom, and I'd write 93, and I would subtract, right? Same thing here. What am I going to put right here? Times the 4x that'll match exactly, same sign, same everything, exact match to negative 12x. Yeah, what times 4x is negative 12x? Negative 3. Exactly right. So I've got to put a negative 3, and it's going to go boom, boom. It's going to hit them both. Negative 12x minus 21. Beautiful. There's a 0 remainder. Here's our answer, 2x minus 3. So like I said, dividing these was close, but it wasn't exactly right. The real horizontal asymptote, oblique asymptote, diagonal asymptote equation is y equals 2x minus 3. So you got a long divide to make that happen. A little messy there. I want to be straight with you. You know, I always want to be straight with you. There's only one of these in the homework. It may or may not be on the next exam. I can't remember. There might be one. There might not. I'm not going to give you like 2 of them for sure. You know, so it's not. So you know, like you see my exams, and you see the practice exam. They're the main things. This is small. I mean, we'll do it once. Probably no. It's only one homework question. So don't spend your life, you know, worry a lot about this. There's only one in the homework. You know, master the things there's lots of. Those are for sure. So this might not even be on the next exam. There might be one. I can't remember. Something like that. It's not the biggest deal in the world. So worst case. We good there? Anything else I can answer on that?
I think there's no vertical asymptote.
No, the vertical was right here.
Because like I tried it and you have to factor 2.
Oh.
And then you in the first in the 16 you do the same thing.
Oh, does it cancel out?
Yeah.
Oh, I did. Thank you. Let me fix that then. Let me go back. So let me do it. Thank you for the heads up. Yeah, let me know when there's things I'm not realizing in the homework. Thank you. Yeah, I guess that top factors and it cancels. I'm not going to give you something that tricky on the test either, because it tricks me. If it tricks me, it's not fair. No. All right. So I guess it factors. So I'm going to guess 4x plus 7 since y'all are telling me. So then the other one must be minus 3. Is that right? 8, that'd be what? 8x squared. That'd be, I don't know, let me see, 14x. And the outer 2 would be minus 12. Oh, yeah, that's plus 2. Beautiful. Yep, you guys are right. They're being tricky. Thanks for the heads up. 4x plus 7. So those cancel, and it's just 2x minus 3. There is no vertical. So no vertical asymptote. Thank you. It cancels out. That's tricky. I'm not going to try to trick you that way.
They will, but
Yeah, so it's good to see one tricky one in the homework because it's possible as you move on into calculus, but it's not a main thing.
eliminate the idea of the.
So no vertical, and we got the horizontal was y equals, what was it, 2x minus 3? Yeah, 2x minus 3. 2x minus 3. So there's the real answer. No vertical, horizontal is y is 2x minus 3. Thank you. All right. Here at the end, these last few. It's the last case. There's a fourth case for the it's a simple case. We've done the hard one now. I'm not gonna do the, well, or maybe I'll do it quick. All right. Yeah, I guess you got to factor the top now just to be careful. X squared minus 16, x squared plus 16 on the top, which then you can go x plus 4, x minus 4. We did this one a minute ago, right? And then the bottom, take out a 3x, leaves x minus 4. Is that right? Yeah, 3x squared minus 4. Yeah, because you multiply that to go back. Oh, yeah, look at that. They're being tricky again. See the x minus 4's cancel. Yeah, those dirty dogs. Yeah, they're being tricky. Okay, so when you're done, it becomes this after the reduction. And so now we take the denominator. I'm doing the vertical. All this is the vertical. Right, so for the vertical, you do have to factor top and bottom and cancel right there. And so now we have that is the reduced fraction. Now you take denominator that's left equal to 0. So that'd just be 3x equals 0. So you know that's just divided by 3. X is 0. Scribble in there. X is 0. So the vertical is only x is 0. Good for that one?
Where the 4 come from? The minus
Yeah.
4 on the bottom.
I told the other class the wrong answers on this one because nobody spoke up. And I don't have time to do them all the way out. I keep trying to cut corners, but then I miss little things like this. All right. So anyway, now let's do the horizontal. The horizontal has a new case. In fact, I'd like to, if you guys have got that copied down, I'd like to write the whole story for horizontal. So I'm going to do that. I'm going to move on. If you didn't get that, it'll be on the YouTube. So now Because so let me write all four cases now for you for the horizontal story. So for horizontal asymptotes. So you got the numerator denominator thing. Okay, so if numerator equals denominator, we already know it's y equals a over b. If numerator is smaller than denominator, then denominator wins and it pulls it flat to 0. If numerator is greater than denominator by only 1, then it's a oblique or diagonal asymptote, y equals mx plus b, long divide the denom into the numerator, right? As we just did. Okay. Now, case 4 is if the numerator is greater than denominator by 2 or more. That's what we have here. See how the numerator is 4 and the denominator is only 2? So if the numerator is a lot bigger than the denominator, that's what we're saying, right? If the numerator is a lot bigger than the denominator, when they do the tug-of-war, right, the numerator is trying to pull the graph up and the denominator is trying to flatten it down, who's going to win? The numerator by a long shot. He's 2. If he just wins by 1, then he's going to pull it up as a line. That's the horizontal, that's the oblique asymptote, right? If the numerator only is 1 power higher, like x cubed over x squared, that's x to the first. That's mx plus b. It pulls it up as a dotted slant asymptote line. But if the numerator wins by 2 or more, he just pulls it up, and it's not just a straight line. He just rockets it up, and so there's no horizontal asymptote, no oblique asymptote. There's nothing. Oop, that doesn't look like asymptote. There's none. There's none at all. If the numerator wins by 2 or more, he just takes over too powerfully. The thing is never going to flatten out. It's not even going to line out. It's going to just rocket up because the top wins so dramatically. That's what we have here. So there's none. That's our case. No horizontal, no oblique, nothing at all because the numerator is too much more powerful than the denominator. All right. We